Morning, everyone. I'm Dr. Perera. Today, I'm going to present the paper on behavior of ball bouncing and pace on laboratory cricket pitch models made of local soils in Sri Lanka. Moving on to the content, introduction, which is going to cricket pitch and its importance, reasons for changes in playing characteristics in different pitches, selection of samples, preparation of laboratory models, and laboratory model test, including bounce test and friction test, and pace rating. Moving on to the results and discussion, conclusion, and the references. Going to the introduction. What is a cricket pitch and what is its importance? Every delivery has to pass the cricket pitch before it meets the bat or stumps or the wicketkeeper's gloves, or even a slight variation of pace and bounce or seam due to single crack or grass on the surface will lead to dismissal. Therefore, the cricket pitch is equally important as the bat and the ball in the game of cricket. Going for the reasons for changing in playing characteristics in different pitches, it's a comparison between the world's fastest cricket pitch, the Waka pitch in Perth, and SSC cricket pitch, which is a subcontinent cricket pitch, which is slow and low. First of all, the clay mineralogy is different. In Waka, it's smectite and SSC in kaolinite, and high clay content and silt content in Waka, and low sand content in Waka. The grass type is crouch grass and blue and running grass, which is in SSC, and low organic content in Waka Perth. Moving on to the sample selections. First sample was taken from Moratuwa, which is named as groom soil clay sample. It's a high plastics clay and which is incontaminated clay, which is found as a deposit in Yodhaveva in Sri Lanka. And the second one is the Tyrone clay, which is represent all the test venues in Sri Lanka, where there's only one distributor for the to the clay to the cricket pitches. And next we move on to the Perera sample from Perera region, which is another vastly spread clay, which is a CH clay as well. Moving on to the laboratory preparation of models. First, the ant clay layer, which is a bottommost layer, and the second one is the grass plantation, and third one is fertilizing the grass, and the fourth one is the layer distribution. The first layer is 30 millimeters, and second, third, fourth layers are about 30 millimeters in thickness, which is compacted from 50 millimeters by applying 455 kilopascals of pressure for 120 seconds per layer, which is to simulate the rolling energy of cricket pitch. Moving on to the final appearance of the laboratory models. The top row is without grass and the bottom row is with grass. The difference is in Perera, it's like little dark brown color, which, where the other ones are dark gray color. Moving on to the laboratory model test. First one is a bounce test, which is to evaluate the coefficient of restitution, the E-value of the clay and cricket ball impact. And secondly, which will be the friction test, which evaluates the mu value or the coefficient of friction in between the clay and cricket ball surfaces. Moving on to the pace rating. The pace rating is the ratio between the ball bounce and coefficient of friction, which was found by Murphy in 1985. And here the ball bounce is the rebound height, simple H measured from centimeters, and 4 meter is the drop height. The pace rating is like this: 0 to 50 very slow, 50 to 100 slow, 100 to 300 easy, and above 300 is fast. Moving on to the results and discussion. The Tyrone samples, this is the E-value which is distributed with days. The Tyrone samples start with a high E-value and later displays approximately flat trend line, confirming that there is no increase in the E-value with time. And E-values of Perera and Moratuwa are significantly increased until day 4 and later become constant value. Although the E-values trend lines of the Moratuwa and Perera shows positive gradients, Moratuwa shows higher gradient than Perera until day 4, which implies E-value of Moratuwa increases more rapidly than Perera with drying time. Soft pitch with high organic matter content leads to low rebound velocity with high top spin, while dry firm pitches with low organic matter content will lead to high rebound velocity with low top spin. Moratuwa, Perera, and Tyrone were tested the soil properties previously by Perera in 2016 and found that Morunkan and Kotowera had less than 5% of organic matter, while Tyrone had more than 18% of organic matter. Low organic matter contents of Morunkan and Kotowera has resulted in high E values. And again, wheatgrass samples show constant positive gradients in their E values, trend lines over the 5 days tested. And again, the reduction of moisture content of wheatgrass samples due to the transpiration of grass has resulted on increasing gradient on E value trend line throughout the tested 5 days. Higher rebound could have been achieved if the test was carried out for several days of the samples with grass, since there's a significant gradient in their trend lines in the last tested days. Moving on to the percentage increase of E values of different surface grass conditions. The percentage increase of E values of the samples without grass with respect to the sample with grass are decreased for all clays with days. And the fresh surface grass acts as a damping layer, reducing the E values of the samples with surface grass. In order to compare the contrast effect of the top grass surface on the E values of the samples, percentage increase of E values in the samples without grass with respect to E values of the samples with grass is presented. The shock produced by ball impact on the cricket pitch is reduced due to the presence of thatch of the cricket turf surface. And the top grass layer was dried with time without the water, and grass leaves were indented inside the top clay due to the ball impact. Moving on to the normalized E value by moisture content. The moisture content of the samples cannot be controlled due to the addition of water during the grass plantation and due to the natural transpiration of grass. In order to remove the effect of influence of moisture content, normalized E value, that is E over MC, was obtained by dividing the E value by moisture content. Variation of E over MC with days of the samples are presented in this figure. In here, the E over MC values of Morunkan increase with days, while Kotowera and Tyrone samples approximately had constant E values. High E values of ball bounce in Morunkan and Tyrone samples were observed at 10% and 15% of the moisture content respectively. Morunkan soil generated higher bounce than the rest of the tested clays at a given moisture content for both with or without surface grass conditions for 80% of the tested day. That means the latter 4 days. Moving on to the paste rating. Here it shows the friction force graph, which was calculated previously by Perera in 2017. And here by the gradients, it is calculated the mu value, which is the coefficient of friction for the same identical samples. And starting from easy paste category, Morunkan and Kotowera shifted to fast paste category from day 3 onwards. And the paste rating was graphed in front of the days. And Morunkan and Kotowera can be maintained as fast paste category by maintaining the required moisture content at the start. And Tyrone has been shifted from fast to easy paste category after the day 1. And the Tyrone exhibits fast nature only in the first day due to the excess surface moisture available in the start. Moving to the conclusions, the laboratory models made from Morunkan soil demonstrated the highest E values in both without surface grass and with surface grass conditions towards the end of 5 days of the ball bounce test. Sample without grass showed higher E values than the sample with grass during the 5 days tested. The samples with surface grass displayed higher increase in E values than samples without grass throughout the 5 days tested. EOMC resulted showed that Morunkan can generate higher E values than other samples at the given moisture content. Optimum rate of the moisture contents to operate Morunkan, Kotowera, and Tyrone in fast category was identified as 10% to 12%, 18 to 19, and 20 to 21 respectively. And for the further studies, Morunkan and Kotowera can be used to prepare local cricket pitches under actual environmental conditions of cricket match. And this is a sample pitch which was created or developed in SSE cricket nets in Sri Lanka. And the pace and bounce test should be conducted on such field pitches, and their values should be compared with the Australian fast and bouncy cricket pitches in the further studies. And this was conducted in Australia currently, and the ball bounce and the pace was recorded here. And references, thank you very much.